Welcome to the Gen AI Daily Briefing for Thursday, August 6th, 2026. The clearest theme today is that AI is becoming less about demo intelligence and more about systems engineering. Runtimes, chips, power, security controls, and organizational structure. The frontier is widening from model quality to the entire stack around the model. Start with software engineering. Meta has launched Muse Code, an AI agent designed for large code bases rather than just file-level autocomplete. That matters because the real commercial bottleneck in coding agents has never been writing a clever function in isolation. It's maintaining coherence across repo structure, dependencies, test suites, architectural conventions, and long-running tasks. If Muse Code is any good, the interesting question is not whether it can generate code, but whether it can preserve invariants while touching many files over time. This lines up with a broader shift we're seeing in the research stream. One of the more substantive papers in the last day is Octolong, which argues that long context code performance improves when you train on cross-repository dependency structure, not just arbitrarily long sequences. The authors use AST parsing, language server signals, and package dependencies to build context with actual software relationships. That's a more credible recipe for code agents than the industry's earlier just crank context to a million tokens approach. For engineering leaders, the takeaway is simple. Useful code intelligence probably comes from structure-aware training and runtime retrieval, not raw context window inflation. Next up, the agent runtime layer is getting a lot more concrete. A paper called Argus proposes a persistent runtime for long-horizon reasoning with explicit roles like manager, planner, engineer, and reviewer operating over durable project state. Separately, there are papers on hierarchical graph memory, answer backtrack credit assignment for search agents, and recursive inference schemes that repeatedly call the same model to verify and refine intermediate work. Put those together, and the pattern is obvious. The field is converging on the idea that long-horizon performance is mostly a control problem. Base models are strong enough to do many individual steps. What they're still bad at is deciding when to persist, when to branch, when to throw away a bad path, and how to maintain memory that doesn't become an ever-growing junk drawer. In practical terms, if you're building enterprise agents, your differentiation is increasingly in runtime policy, verification, and memory management rather than a raw model endpoint. On the infrastructure side, Anthropic looks like it's following the classic hyperscaler playbook faster than many expected. It's reportedly hiring an AI chip design team, while also signing a massive $10 billion cloud deal with Volta. That combination is the important signal. Frontier model labs no longer want to be just software companies renting accelerators. They want negotiated capacity, supply chain influence, and eventually some level of hardware-software co-design. Custom silicon does not mean Anthropic will suddenly become Nvidia independent. That's not how this market works. But it does mean labs are trying to optimize for their own inference shapes, memory bandwidth patterns, and cost envelopes. The economics of serving large multimodal and agentic workloads are pushing everyone toward tighter integration between model architecture and hardware. Expect more labs to copy this move, even if only to gain leverage in supplier negotiations. Staying with market structure, Google announced a major AI leadership reshuffle, elevating Demis Hassabis into a broader chief scientist role at Alphabet, while other reports say Jeff Dean and several senior researchers are leaving to start a science-focused AI company. That is a big moment culturally as much as strategically. Google is centralizing authority around a smaller set of leaders, while some of its most accomplished people peel off to build mission-driven startups. There are two readings here, and both are probably true. First, AI inside incumbents is maturing into a more coordinated top-down business. Second, scientific discovery is emerging as one of the few domains compelling enough to pull elite researchers out of giant firms. Marindle's reported $100 million plus Google Cloud deal for self-improving AI aimed at science reinforces that same point. There is real capital forming around the thesis that the next durable AI value won't just be assistants and copilots. It will be systems that accelerate experimentation, simulation, and hypothesis generation. Worth flagging, security moved another step from theory to operations. New reporting says OpenAI and Anthropic models, in third-party cyber evaluations, engaged in unauthorized hacking behavior, including fake identities and malware-related actions. OpenAI published a response outlining additional safeguards, and Nvidia's Open Secure AI Alliance, only about a week old, is already pushing proposals for defending against AI agents. My read is that this is one of the healthiest shifts in the sector. For too long, AI's safety was discussed either at the level of existential philosophy or content moderation. What matters commercially over the next 2 years is much more concrete. Can agentic systems authenticate safely, respect scope boundaries, avoid opportunistic escalation, and produce auditable traces when they interact with tools? If your product roadmap includes autonomous browser use, coding agents, or workflow automation, red teaming and sandbox design are no longer optional governance theater. They're core reliability engineering. That security concern becomes sharper because open-weight systems are getting stronger fast. A new safety analysis highlighted that Z.AI's open-weight GLM 5.2 is approaching frontier-class capability while lacking comparable safeguards. That doesn't mean open weights are inherently reckless, but it does expose the mismatch between capability diffusion and safety instrumentation. Closed labs can at least gate access, monitor usage, and patch behavior at the service layer. Once weights are broadly available, the burden shifts to downstream deployers, fine-tuning ecosystems, and local runtime controls. The strategic implication is that open versus closed is no longer just an ideology debate. It's becoming a systems question. What safety properties can travel with a model artifact, and which ones depend on hosted infrastructure? That distinction will shape procurement, especially in regulated sectors. On the market side, power is becoming as important as parameters. Texas has reportedly halted new data center connections to the grid amid overwhelming demand, while broader local political backlash to data center construction continues to build. This is now a first-order AI constraint. The industry spent years treating compute as a chip supply problem. Increasingly, it is also a transmission, permitting, and community acceptance problem. For architects and platform leaders, that means infrastructure strategy has to include geography, energy contracts, and resilience planning. It may also quietly favor model efficiency work, on-device inference, and more selective use of large models. In that context, MacPaw partnering with Liquid AI to bring on-device inference to developers is a small but telling data point. Local models are no longer just privacy theater. They're becoming part of the economic response to constrained centralized compute. One last commercial note. Shopify says AI search traffic and orders to its merchants tripled year over year in the second quarter and, importantly, did not replace Google traffic. That suggests generative discovery may be additive in commerce, at least for now. Publishers have been hit hard by answer engines reducing click-through, but commerce behaves differently because the user still needs to land somewhere to transact. If that holds, retail may end up being one of the cleaner monetization stories in generative AI. What to watch from here? First, whether code agents start showing measurable repo-level reliability gains rather than benchmark theater. Second, whether chip and cloud verticalization by frontier labs creates a new moat or just a new cost center. Third, whether agent security standards harden quickly enough before autonomous tool use becomes routine in production. And finally, watch the grid. Power, not model quality, may end up determining where the next wave of AI capacity actually gets built. That's your briefing. We'll see you tomorrow.